Welcome to this video on properties of matter. So far you've learned about classifying matter, that is, trying to decide whether a particular sample of matter is a mixture or a pure substance, and then based on that determination whether or not it's an element or a compound or a homogeneous mixture or a heterogeneous mixture. Now we are going to talk about properties of matter. And so what do we mean by properties? Well, probably the simplest way to answer that is just to show some. So all matter has properties, and for example, any sample of matter, whether it's a mixture or a pure substance, has mass, and we can determine that using a balance. Has density. Density is defined as mass per unit of volume. Any sample of matter that's a liquid, for example, would have a particular boiling point. We could talk about whether or not it's possible to burn a particular sample of matter, so that would be its flammability. Any sample of matter is going to occupy some particular volume. So these are refractive index is a little over the top, but these are some examples of properties of matter. Now we can in physical state too. And so one final way to think about properties of matter would be its physical state. Is it a gas? Is it a liquid? Is it a solid? Is it a mixture of those things? Now a mixture, so again, we've already learned about mixtures versus pure substances. Mixtures have variable compositions, therefore they have variable properties. And a good example of that would just be to say sugar water. And you can measure the density of sugar water. Again, density is mass per unit volume. So if I had a solution of sugar water, I could measure its mass and I could measure its volume and therefore calculate its density. But the density of a sugar water solution is not a fixed property. It depends on the concentration of the solution. So the more sugar I have in my sugar water, probably the more dense it would be. The less sugar I have, the less dense it would be, etc. So this is just an example of the fact that mixtures have variable properties. And here's another one that I learned when I was a kid playing with a chemistry set in like third grade. If I've got a solution of rubbing alcohol, which is called isopropanol, in water, if it's like 70% isopropanol in water, that is flammable. But if it's maybe only 20% isopropanol in water, that is not flammable. So mixtures have variable properties, but pure substances have fixed properties. And that's really what we're going to sort of spend our time thinking about today. Now, there are different ways of classifying the properties of matter. We're mostly going to focus on classifying them as either physical or chemical properties. But there's one other thing that you need to learn, and that's the concept of the extensive versus the intensive property. And so let's just go over that really quickly. Extensive properties are properties that depend on how much of the substance is there. And so let's say I've got a sample of water. One of its properties is the mass of the sample. Well, that property is going to vary depending on how much water is present, right? So if I've got a lot of water, it's going to weigh more than if I've got a little bit of water. If I've got a lot of sand, it's going to occupy a larger volume than if I've got a little bit of sand. And so extensive properties are properties that depend on the amount of something that you have. But then you can think of another set of properties called intensive properties, and those do not depend on how much material you have there. So for example, the density of water is the same regardless of how much water you have. And so if I have more water, it'll have a greater volume, but it'll also have a greater mass. And that's a linear relationship. So the density remains constant. The melting point of ice is going to be the same no matter how much ice I have. So those two things you need to remember because they will appear on assessments. Extensive properties depend on the amount of substance present. Intensive properties do not depend on the amount of substance present. They are intrinsic to the substance. The rest of these slides, though, we're going to talk about physical versus chemical properties of matter. And so let's get on with that. And the simplest way to look at a property of something and decide whether it's a physical property or a chemical property is just to ask this question. In order to observe it, are old substances being destroyed and transformed into new substances, or are they not? If no change in the identity of the matter is occurring, then in order to observe that property, then that's a physical property. So for example, melting point. If I melt water, if I melt ice into water, I'm not actually changing its identity. It's still water. And so melting point is a physical property. But if I put an electrical current through water and I separated it into hydrogen gas and oxygen gas, that would be a chemical property of water because I'd actually be destroying the water and creating something else. So if the answer is no, it's a physical property. If I'm not changing the identity of something, it's a physical property. If I am changing the identity of something, it's a chemical property. So the physical properties of a substance can be observed without destroying it or changing its identity. Density is an example of that. To measure the density of a substance, let's say a piece of metal, I determine its mass, I determine its volume. I don't change the identity of the metal in making that determination. Melting point I just mentioned with regard to something like ice, and there are other things that we can melt as well. The color of something is something that I can observe without changing its identity. I need to get refractive index out of here. Refractive index is basically the speed that light travels through something. And so, but anyway, and mass. So the mass of an object I can measure without changing its identity. Let's talk about some chemical properties, because in order to observe a chemical property, you have to actually destroy the thing that you're talking about. So the chemical properties of a substance can only be observed by transforming it into something else. And really, this all comes down to chemical reactivity, which is a blanket term that covers some of the other things I'm going to list here. So for example, flammability is a property of gasoline. If I light it on fire, it will burn. But in the process of observing that property of gasoline, I'm actually changing it into something else. So when the fire goes out, there's no gasoline left, and I have converted it into things like carbon dioxide and water. Reduction potential, that's something that's more of a AP chemistry kind of thing, but that's something that I would, in order to, so this is what happens in batteries actually, is that things are, in order to, certain substances have electrochemical properties and can generate a current. But in order for those properties to be manifested, the stuff has to be destroyed or turned into something else. Radioactive half-life is something you may have thought about or heard, which is like certain elements have unstable nuclei, and so they will decompose into other elements. That's a chemical property, because the only way you can observe radioactivity is to observe a thing being turned into something else. Okay, physical and chemical changes are closely related to physical and chemical properties, and the way of determining whether a particular change is one thing or the other is to ask the same question: are old substances being turned into new substances or not? And if the answer is no, then that would be a physical change. If the answer is yes, that would be a chemical change. So a physical change does not change the identities of any substances involved. So for example, if I freeze water, I am not changing the identity of the water, I'm only changing its physical state. If I boil water, I'm not changing the identity of the water, I'm only changing its physical state. If I mix things together, if I mix some salt into water, I am not changing the identity of the salt or the water, I am mixing them together. Dissolving would be, Dissolving is a specific type of mixing, and that's actually what I just described. Another type of mixing in which I'm not dissolving might be mixing some sugar together, just some sugar crystals together with some salt crystals. Filtering. If I have, say, some sand and some water and I want to separate the two, I can filter the sand. I can put it through a filter and the sand will remain behind and the water will go through. That's a physical change because I am not changing the identity of either of those things. I'm simply separating them from each other. And so that's an example of separating. A chemical change is going to result in an old substance being destroyed and new substances being formed. So I mentioned combustion of gasoline, and so we'll just say again, that's kind of the most obvious example. Burning stuff is the most obvious example of a chemical change. Iron will rust. Other metals will also oxidize or tarnish. Those are example of chemical changes. I mentioned earlier that you can actually run an electrical current through water and you can generate hydrogen gas and oxygen gas. That would be an example of a chemical change because the water is actually being destroyed and turned into new substances. Okay, well, that's the end of the slides. So there is a worksheet associated with this. And so the assignment will be to do the worksheet before the next class. And thanks so much for watching.